One thing you've got to remember that is different from an equation to an expression. In an expression, nothing can ever go away except when you cancel out. So you can't say, oh, take the minus out and then the minus disappears. That doesn't happen. That can only happen in an equation. So in an equation, I see already now, there's many ways to think about this, but the first thing that I see is, I know I'm going to factorize. So immediately I know that will be a problem. I don't like that in the front. So there's many ways to go about it. Some people say I divide with a negative right through. Others say I factorize a negative out. Other people say, oh, it's much easier, sir. I'm just going to do this. I'm going to take everything to the other side, which is also a good way of thinking about it. I just need to get that thing in front a positive, because I don't want the negative thing. Okay. Now, what we did from there, I said we can cheat. But what should happen is I should use what we call the factor theorem. In other words, we need to substitute values to get to an answer of 0. Because if the answer is 0, then I know that value would be a factor. Okay, so that I know. Just see the calculator open here for us. Vandaag nog? Okay, it takes too long. Ms. Fitzgerald, can I ask you what value did you substitute here?
So I substituted 2.
Okay, so if you substitute 2, she did the factor theorem, and I do this because I know she used a calculator to get one of those. So I substitute 2. So when I substitute 2, what's going to happen? I'm going to get this. 2 to the power of 3. Now you see I take the 0 away now. I'm just looking at the expression section. Okay? Minus 6, and that x will become 2 to the power of 2. And then I would get plus 5 times 2 plus 6. And I did it on my calculator, so I know it's going to be 0. And then what's my deduction that I make from that? My deduction then is the following. Therefore, x minus 2, always opposite sign of what you substituted, is a factor. And without this thing, you won't be able to solve the equation. Okay, so the next step would be, then I know I'm going to have x minus 2 as one of my factors. And I'm going to ask myself, all right, remember, I'm going to use the yellow one now. I simplified it by taking the negative away. So I said, with what should I multiply that x to get to x to the power of 3? And the answer would be x squared. With what should I multiply that negative 2 to get to positive 6? And the answer is negative 3. Very important. Now you've got to have that. Otherwise you can't solve it. And it's not an equation. Equations can be solved, expressions can be simplified. Okay, so now I go and I say, all right, and this is the most difficult section. I do this always in pencil here. You don't have to. Just for you to see it visually. So what happens now is I'm going to multiply those 2 and multiply those 2. It's always those. Always going to be that. So those 2 are going to give me negative 2x squared. Those 2 are going to give me positive bx squared. And then what is it equal to? I go back to my equation. And it will be equal to the x squared in there, which is minus 6x squared. Which translates to this. Minus 2 plus b is minus 6. Just take the x's away. Which means if I solve b, 2 will go across, it will become minus 4. Which in turn will go in there. Minus 4x. Now that second part at the back is a quadratic equation. And hopefully all of you know how to solve a quadratic equation. But luckily, if I'm not certain here, I may use the what? The formula. Not the calculator, the formula. The formula that says x equals minus b because I'm solving x. Now let's see here. I need factors of 3 to subtract to get 4. Not a chance. Not a chance of that happening. So what do? I go to my formula. So if I go to my formula, the formula states this. X equals minus b plus minus the root of b squared minus 4ac over 2a. Yes,
If you have factors of 3, create 1, and
but you should subtract.
you say if you have minus 3 minus 1, it's minus 4.
Yeah, but that's another way of thinking about it. I don't, yeah, you can, no, I'm going to use my formula. Alright, so if I use my formula, I'm going to say, alright, negative b will become positive 4 in here, plus minus the root of. Then it would be negative 4 squared minus b, not b. So that would become, just close it up, it's going to become 4 times a is 1, times c is negative 3. Everything over 2 times 1. Now let's see if my calculator opened it this time already. It seems, do you have the answers? I think I have a calculator as well. Did you use the formula?
No, it's
Okay, so let's see if we get to the same thing. So I'm going to go and take my calculator, I'm going to type that in. So I'm going to get 4 plus root of, I know that's going to become 16, and I know that's going to become plus 12. Plus 4 times 1 times 3, yes, and everything is over 2 times 1 is 2. I get that. Which is 2 plus the root of 7. So I get x is equal to 2 plus the root of 7. Or, now I go back to my formula, and then I just substitute that. And normally what happens is just change the signs as well. So this will become 2 minus the root of 7, or if I'm not mistaken, we already had one. That was this one over here, which will be the 2. And there's my 3 answers. Now, be careful, please, grade 12s. Read what they ask you. Sometimes in this question they say leave your answers in insert form, then you don't have a choice. Sometimes they tell you round your answers to 3 decimal places. Then you can't leave it like that. And if they say nothing, then you choose. So you can go for the decimal, I've got no problem with that. So you want to go plus root 7, and that would be 4.65. And if you go the other way, and depending on how many decimals they want, minus 0.65. And that's your x-intercepts. So just to give you a little bit of a background again, we set mark yesterday. What are those things I just got? Those things are the 3 x-intercepts of a graph that I'm going to draw in the next chapter by making use of a differential calculus. Fantastic. The next one was 7. Am I correct, Fitzgerald? So 7 says this. 7 says x squared. Then it says plus 4x. Then it says plus 1, and then it says equal to 6 over x. Alright, so we said yesterday, before I can do factor theorem or anything, I first need to be in standard form. That is not standard form. So, immediately, what I see, immediately when I wrote it down, my head goes ding, 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 there's a fraction. What do I know about equations and fractions? Get an LCM. If I have an LCM, the denominator falls away. Some of you would say, sir, I'm going to take this x across, and if I take it across, it was divided, so I multiply. Same way I was thinking about it. But what you should get is this. x3, 4x squared, x, and 6. Then 6 will go across. And then this thing would look like that, which is standard form. Okay, so now, for those of you who've missed it, remember what I said. If you don't have this calculator, you start substituting 1, see if you get 0. Minus 1, if you get 0. 2, en ek het vir my klas gesê, vir die wat nou gemis het, vir Afrikaans sê, dan geef my sê, maar meneer, sê nou maar die eerste waarde is 50. It's not going to happen. Ons is nou nie onnoosel nie. So we're always going to give you one of the factors are going to be anything from 1 to 3. Somewhere there. So you won't sit for half an hour and go. So On the calculator, mode equation, cubic is 4. So it's 1, 4, 1, and negative 6. Ah, thank you very much. I stopped there. So 1 would be the option. So what I'm going to do is, and I have to indicate this, ladies and gentlemen, they want to see where you did the factor theorem. Even though you're actually a little bit lying now, because you didn't do the factor theorem, you cheated, you show that to them. So that gives me naught. So the deduction is what? X opposite sign minus 1 is a factor. Fantastic. Okay, so now I'm going to go x minus 1 bracket. So with what should I multiply x to get to x3? And the answer will be x squared. With what should I multiply minus 1 to get to negative 6? And the answer is plus 6. Please remember your equal to 0. And here I've got bx in the middle. So if I do my multiplication, I'm going to get minus x squared plus bx squared equal to what? Equal to the x squared in there, which is 4. 4x squared. Minus 1 plus b equals 4. b is, 1 goes across, 5. So this I erase. 5x. I need factors of 6 to add to get 5. Boom, this one works out nicely. That would be 3 and 2. So I'm going to get x minus 1, x and 3, x and 2, everything naught. Signs are the same. Both are pluses. X is 1 or negative 3 or negative 2. There's my 3 answers. Okay, ek gaan dit nou gaan Afrikaans sê. Daai lot wat in hier was nie, vra is dit Grieks wat ek nou geskryf het? Het jy dit al ergens gesien, Delport? Okay, fantasties. Alright, I go on. Last one, number 10. Number 10 says this. It says x to the power of 3 minus x squared minus 5x, and then it says plus 6 is 0. I just want to say something here, ladies and gentlemen. You will always, and keep this in mind as we go on, I said, this is a cubic function. What do I expect? I expect to get 3 answers. But you're not always going to get 3. You're always going to get the minimum that you're going to get is 1. Remember yesterday I said you can get that it's the same. So you can get an answer, for example, you can get an answer that says 1 minus 3 and minus 3. But it's the same. Here we know it's a turning point. But what happens, and this could happen, what happens when that quadratic one you have there does not work out? If you put it into the formula, it indicates to you an error. In other words, imaginary answers. If you type into the calculator, it's a weird thing with a little I at the back. That can happen as well. Then you only add 1, so the minimum is 1. So don't get stressed. I don't know if this one is going to work out like that. But don't get stressed when you get that. Because what happens then is the graph, which we're going to draw at the end, then most probably will look something like this. And this you won't understand now. But that can happen as well. So don't just, it can happen that you only get 1. We expect 3, but there are scenarios where it can't happen. Okay, so here we go. So I grab my calculator. I'm going to go clear my screen. 1, negative 2, negative 5. What was that last thing? Plus 6. Plus 6. I don't need to add the plus. Okay, so then I've got negative 2, 3, and 1. Okay, fantastic. I'm going to go for 1. So I start off and I say, alright, so if I put 1 in there, factor theorem tells me that the answer is 0. The factor theorem says if that happens, therefore x minus 1 is a factor. And this one works out pretty decently if I look at what we just had there. So now I know I've got x minus 1. With what should I multiply x to get to x3? The answer is x squared. With what should I multiply -1 to get to positive 6? And the answer here is -6. Remember, you're equal to 0. Now I've got here bx in the middle. So I'm going to get minus x squared plus bx squared equals, what should it equal to? Minus 2x squared. And then the x's fall away, so I've got minus 1 plus b is -2, which means b is -1, which means I can take this out there and write in -x. So I need factors of 6 in the quadratic to subtract to get 1. Once again, it's 3 and 2, pretty much the same as the previous one. Signs are different. Biggest one is a minus. There's my answers. X is 1 or 3 or -2. Okay, everybody's fine with that. I'm moving on to differential calculus. So yesterday, I actually just said a lot of things about differential calculus just to sketch a little bit of a background in terms of this. So we said, what is differential calculus and why we use it? It's all about movement and determining stuff when moving. They actually quoted in the book that I have, they quoted saying that Mark Shuttleworth is one of the people that actually made use of this in terms of when he did the moon landing thing. But I also think they made a pretty big deal about him. And actually what he did was, he was just the first South African to get onto a thing to go somewhere, but okay. But ladies and gentlemen, all that we need to know is it's all about calculations with movement. That's what it is about. All right. I just want to open up here. What book do I have here? This is grade 12. Why does it seem so weird? It looks like grade 10. Okay, so then we said the next thing we need to understand is what is a limit. Okay? So a limit, and I know if I look at these stuff separately, it's like, what the hell? And they also say they're going to look at the limit in a lot more depth when you get to university and you do calculus there. All that we need to understand is that a limit is when I have any function. So what we did here, I'm just going to explain it again. I gave you that, which is a quadratic function. Okay? Which means the picture will be a parabola. So I asked the class and said, what can x be? In other words, what's the domain of that graph? And the answer was, sir, it could be any x. X is an element of real. So it could be anything. So I said, all right, let's choose one. So I choose the one that the book said. The book said let's choose 2. But you could have used anything. So what we're going to do is we're going to have a look at what happens to my y when I approach a specific x. That x could have been 3, 4, 1,000, doesn't matter. Okay? So we just choose 2 for this example. So we said, if I take 2 and I put it in there, the answer would be 5. Correct? That's what I have there. And what we then started doing is we approach the value 2 from both sides. So if 2 is in the middle, we approach from the left and the right. And that's what we did there. And what you should have seen is that the closer we move to 2 from the one side, I move closer to 5, and from the other way as well. So that table I will never ask you, I just want to see it visually. So then they say that is what a limit is. A limit, look here, is a value of y, I said answer in brackets, that we move closer to as I move closer to a specific x. That's a limit. All you need to know in grade 12. You can go into much more depth, but that's what we need to understand. Why do we need to understand that? Because we're going to see the word limit as we move on. And then I did a few calculations and I said, this will never be asked in grade 12. In the 14 years I've been teaching, this was never asked before, even when I was in school. But I'm just going to show you. So we say here, and what's very important here is the way we write it. I also said yesterday, the nitty-gritty things in this chapter. They're going to penalize you on writing the wrong abbreviation, stuff like that. So what they're telling me is they said calculate the limit. So that's for limit. They want to know What is the limit when x tends towards 1? So what we do is we always simplify the thing, which can't. If I can't simplify, I substitute. So when I do that, I get 6. So in other words, I know the answer is 6. I know that. That's the limit. I mean, it's the highest, but when I approach it, in other words, when I get closer to that x, that's going to be the 6. That's the concept I need you to understand. I know you substitute 1, I know the answer is 6. You just need to know, when I put values before 1 and after 1, I'm going to move closer to it. We're going to get closer to 6 as an answer. Yes?
So, if you go to, can you please go to the table which we did? So, the value that we put into 85 is our reference, I guess, that we work on.
We decided to use the x value too.
So, if 1 on the very top is the x coordinate, and is y, then is 2 then the y coordinate.
Correct.
So it doesn't make sense for me because when you look at that parameter, when you move up in x values, you move down.
It depends on what parabola you have.
So is that not an accurate?
Okay, so in this case, 2 would be, if we use this sketch here. Now let's say 2 is here, correct?
Yes.
Alright, so if I put 2 in, okay? 2 can't be there. I'm speaking absolute nonsense. That's the wrong side. 2 is there. Okay, so that's 2. Alright, so if I put 2 in, I'm going to get an answer here of 5, correct?
Yes.
Okay, so now what I do is, I'm going to move you with me. Okay, so already answered yourself. Alright, fantastic. Alright. So, ladies and gentlemen, I just showed you one of the things I said yesterday, remember this. When you see this limit abbreviation, that thing stays written there until the moment where you substitute your x. So, look at this example. I factorized to simplify. You see this stay here the whole time? When does it fall away? As soon as I put the 2 in. Alright, so that's it. So then I said, let's have a look at first principles. That formula is the formula that we use for first principles. Today I'm going to show you how to calculate your derivative. Now there's a long way and a short way. So I said yesterday, I'm just showing you this. It is not examinable. I'm not going to ask you this, but just have a look here. That is the formula to find what we call your first derivative. That is the abbreviation for first derivative. I said be careful. Remember we did that at the beginning of the year. That is inverse. Ek weet die kinders gaan dit ook hier. Okay? So that's the formula. Where did I get that formula from? So the formula I showed in the long explanation, it is actually just your average gradient. Okay, but the difference is, and I substituted everything, I'm going to go through the whole thing again. But the difference is what? That limit where x tends towards 0. So what it's saying is, not x but h. That is h. Okay, so h is tending towards 0. So whatever h shall be, let's say it's 5. So here is 5. So I'm going to go from here and I'm going to start putting in h values towards 0. Now every time that I substitute a specific h, so let's say 4, I'm going to get an answer. And that, ladies and gentlemen, is that point over there. Keep that in mind because we're going to get to what that formula at the end does later on. And if I substitute one closer, I'm going to get an answer there. If I substitute one closer, I'm going to get an answer there. And at the end, you know what that's going to be? Where did we get that formula from? From the gradient, correct? So you know what that little thing is going to be to us at the end? It's going to be nothing else but if I have tangents there, the gradient of that tangent to that point. And that's where the whole thing then starts to start becoming more a little bit applicable. For now, I'm just showing you theory. Okay, so let's do a first principle. So that's where I want to start today. So, ladies and gentlemen, first principles. When do I do this? Only if they ask you to do it. Okay? Otherwise, you use the short method. So the question would be, by making use of first principles, please find the derivative of. Okay, so let me give you an example. You can write today's date, which is the 24th of the 6th. Okay, if you can write there finding, and please, ladies and gentlemen, don't, no, I don't know, I hope it's spelled correctly. That's not, I don't know, derivative, but okay. Luckily, I'm not an English teacher. I know nothing about Shakespeare. Right, so finding the derivative. Alright, so this formula that I showed you yesterday is the formula that we use to find what we call our first derivative. So it says the f of h plus x minus the f of x over h. Now, grade 12s, we've got a mixed pool of children every year which writes into exams. We spoke earlier about a week or two ago, I said about coaching. In coaching, one of the things we say is there's stuff that's easy, do that, get the marks. Now, I'm saying this now. This, like proving a theorem, is freaking 5 to 7 marks that every single person in this class should get. If you're a 90%er or if you're a 40-30%er, you should get this. This is easy marks. Because they always ask this in the simplest functions. It's not going to be difficult functions. And secondly, it's always the same way to do it. So please have a look. I'm going to refer to your textbook here. There would be an example in your textbook on page vanuit eerste beginsels. On page 150. And I'm going to do that one so that if you want to go afterwards and rewrite it, you're welcome. So they give you this. They say the f of x equals, and then it says 2x to the power of 2 minus 3x minus 5. Now immediately you're going to tell me, so I thought it's all about cubic. No, it's not all about cubic. It's all about curves. Any curve. It could be a parabola, it could be whatever. So don't break your head on this. I'm going to really tell you the answer. What's the first derivative of this thing? Now those of you who already did a little bit of this, you would know this. But the answer is going to be 4x minus 3. Okay? I'm going to show you how to do that very easily, but first we need to do the first derivative. So they're going to say, get the derivative of this by making use of first principles. Then you use this formula. So in this formula, we find an fx plus h, and we find an fx. So fx I have, you see that? Here it is. That f of h plus x. Now there's two ways of thinking about it. Some kids want to, and I personally want not try that. That is like driving a car on the highway at 120 on the N1 in traffic and trying to eat fish and chips, which is warm. That is what we're doing. It's going to be a bugger. Okay? So please do this separately. Don't do it in there. So the first thing that I do is I go and I say, let's go and find out what is the f of x plus h. So how do I find the f of h plus x? Ladies and gentlemen, that is a straightforward substitution problem. I have the f of x, correct? So if I tell you the f of x plus h, what's going to happen? Everywhere in that thing where there's an x, what am I going to go and write now? X plus h. So let's do that. So I get 2x plus h squared, 3x plus h minus 5. And then I simplify, okay, before I do anything further. So let's simplify. So I'm going to get 2x squared, 2xh plus h squared minus 3x minus 3h minus 5. That's going to become 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 5. And there we are. And that's how far I could simplify that thing. So what you now have is the simplified form of that f plus h. Okay, so now you have that. Don't try and do that in the formula. You're going to make a bugger. Okay, so now what happens next is, now I'm going to use my formula and apply that. So the formula said, and I'm going to start off with the first derivative of fx. Die eerste afgeleide van fx. And once again, the way I write it is very important. Yesterday I mentioned it as well. You see there? Equals limit h tends 0. Not limit h tends 0 equal. The equal is in front of it. When does that limit fall away? Only when I substitute naught in h's place. Because that's what I'm going to do. So now I have this. Limit h tending towards 0. Okay, so now I substitute. Now I'm just going to make my pencil thinner for space-wise. So we have this thing. Am I correct? 2x squared plus 4hx plus 2h squared minus 3x minus 3h minus 5. Just going to move this quickly, otherwise I'm going to run out of space. Okay, fantastic. That's my fx plus h. Then it said minus. What should I minus? Go back to the formula. It said minus fx. What is fx? This is this thing, isn't it? So now I'm going to have minus. And remember with the minus, boys and girls, keep that bracket, eh? It's going to make a huge difference. Everything on h. Okay, right. Now I simplify. But before I can simplify, equals limit h tending to naught. That must stay there. So if I simplify the top, I'm going to have that and that cancels out. It's going to become 2x squared minus 2x squared. Then I'm going to have this cancelling out. 3x and 3x because it's minus 3x and that's going to become plus 3x. Gone. I'm also going to have this 5 with negative 5. Now please, boys and girls, what I'm doing now is totally theoretical. You don't go and scratch things out in the exam. Don't do what I'm doing next. I'm a bad example now. But I'm just showing you that. So please don't scratch through this stuff. Otherwise the person marking could say, oh, you scratched it out, you don't know what you're doing. So please don't do that. It's just a bad example that I'm doing. But I'm just going to indicate. So those two fall away, those two fall away, and those two fall away. What am I left with? I'm left with 4xh plus 2h squared minus 3h. Am I correct? That's what I'm left with. Because those two cancel, those two cancel, and those two cancel. Everything's still on h. Now, grade 12, let's make sense of this. If I now put naught in there, I'm going to have a problem, correct? Why do I'm going to have a problem? Naught at the bottom. Okay, so what happens next is, can't I simplify a little bit further? And I said, yes, I can. That top one, can't I take an h out there? So I'm going to have limit as h tends towards 0. And I'm going to take an h out at the top. I'm left with 4x plus 2h minus 3. Everything on h. And it's always going to work like that. Simplify, factorize, and now what's going to happen? The h's will cancel. Am I correct? So my next step is going to look like this. The limit of h tending towards 0. Those two will cancel. And please don't scratch them out, but they will cancel. And I'm left with 4x plus 2h minus 3. Okay, can I simplify any further? Now I can't. So what happens now? Now substitute your h0. And as soon as I substitute h0, the limit abbreviation will fall away. 4x, 2 times 0, minus 3. And wasn't that the answer which I told you right at the beginning? And those of you who know, you're going to think, why on earth? The second short method is so easy. Maar hulle vra die elke keer. You're going to get one. You can't not do this. This is 6-7 marks for free. Any questions? So important to remember. Find your f of x plus h at the beginning. Substitute, cancel until you can't put naught in. Remember to keep your limits until you substitute the value. Are there any questions? Everybody's fine. Ja, that's what you say now. But I'm not there. You're like, verduidelijk is het makkelijk, maar als ek het moet doen. But ladies and gentlemen, this is going to need practice. You need to practice this, otherwise you're going to struggle. Let's do another one. So the next one I'm going to give you, let's take one from my blue book here. And I want to start off giving you now a very exceptionally difficult one. I'm going to do that one just now. Okay, have a look at this one. Okay, I give you this. And I tell you, please find. Okay, so I give you example number 2. I give you the f of x is equal to x squared minus 5x. And I ask you to please find the first derivative by making use of first principles. I can already tell you the answer is going to be 2x minus 5. That's going to be the answer. That's what you need to get. So those of you who can think, where do you think I got the answer from? Just, moenie sê nie, Herman. Moenie sê nie, weet jy weet. Maar moenie sê nie, ons gaan alweer kom. So, those of you who'd like to try it on your own, you're welcome. Those who want to have a look, go. So here we go. So die wat myself probeer gaan, kyk of jy daarby kan kom. So I start off by getting my f of h plus x. So I'm going to have x plus h squared minus 5x plus h. Substitute. Simplify. X squared 2xh plus h squared minus 5x minus 5h. And that's it. Can't simplify any further. Now I go to my formula. And into my formula I'm going to go and substitute now. So I'm going to get the first derivative of fx equals the limit where h tends to 0 of that thing minus then the fx, which was x squared minus 5x. Everything over h. Okay, then I'm going to keep my limit. Limit of h tending towards 0. The x squares will cancel and the 5x's will cancel. So what am I left with? 2xh plus h squared minus 5h. Everything on h. And now you would realize this is easy marks because it's the same thing over and over. I'm going to give you a more difficult example just now. And I promise you, when they ask you this at the end of the year, they're going to keep it easy. First principle, we use an easy function. When we do the short method, I make the function more difficult. So now I'm going to have the limit where h tends to 0, and I'm going to take out an h at the top.
Want hierso sê jy nou 2 jaar voor my hoofd toen ik was gaan by after 2 years as jy sê jy die concepts further dis nie die sound as wat die Afrikaans sê die woorde maak soveel verskil ja, dit is hoe dit werk eintlik die Afrikaans want om te sê maar kan ek dan sê die ek sê die concept want dan het jy sê
All right, so what happens? So what's going to happen now? H and H will cancel, and I'm left with the limit of H tending towards 0 of, dankie julle. And what happens now? Nou gaan ek die 0 instel, so I'm going to get, and that's the answer that I said it's going to be. 2x minus 5. There's your first derivative. Yes, Kathy, luister. Ek gaan nou die kortmetode wys. Voordat ek die kortmetode kom, kyk na hierdie een. Dis die moeilikste wat ek vir jou kan vra met eerste beginsels. This is the most difficult example. So the most difficult example would be something like this, where they give you the following. They say the f of x is equal to, and ek wil nou sommer hier gou kyk, hulle sê dit. Okay, so just a quick question. What is that? Remember what I said. Differential calculus, I'm sorry Jamil, differential calculus is all about movement and change and curves. So that should be a curve. What curve is that, Jamil? You are correct? Hyperbolic function, because the x was in the denominator. Nee. Right, so now they ask you to please go and find the first derivative of that thing by making use of first principles. Jeez. So the first thing that I do is, and I think we can try this one together. So the first thing that I'm going to do, I'm going to say the f of x plus h, and there's not much you can do because this will just become that. And just follow your steps. So what will happen next? I'm going to go into my formula. The first derivative of that equals the limit where h tends to 0. Yes, Jamil?
What does the first derivative in theory mean?
The first derivative in theory for now means nothing to you. But when we get to the practical solution there's quite a few options. But the main thing, Jamil, is the derivative that we use it for at school level for us. That first derivative you use to get the gradient at a specific point. In other words, so just before we go on, you see I got that thing, and that was the first derivative of that fx. So that fx would be a parabola. Now I don't know what the parabola looks like. Let's just make up one. But let's say the parabola looked something like this. Right. There's my parabola. That derivative I can now use to find the gradient at any spot on that graph. So if I had to stop here and say, let's find the gradient at that spot. If I had to take and work out a tangent there, what would that gradient be? So what you then do is, Jamil, we're going to get to that. We're going to have a look at what's my x there. Now let's say the x is -1 there. You take that -1, you put it in there, the answer you get is the gradient at that spot. That's what it does. In theory, what we're going to use it for. There's quite a few other things as well, but that's the basic.
Whereas where the tangent and the graph has equal roots.
Not equal roots, but they are equal. Equal roots means both of them are going to have the same place they go through the x. A root is an x solution. So, okay, but we're going to get to that. Ladies and gentlemen, ek gaan dan eers daar stop. Ek sal hierdie een doen en dan wys ek vir die kort metode.